Hi everyone, this is video log number 5. In this video I will be documenting how to configure your Jupyter Notebook so that you can access it from um, your other computers in your network. So if you want to know how I went about installing Jupyter Notebook in my virtual environment, please follow my other video. The link is in the description. So once that is done, I'm going to, and so the VNV virtual environment is here, and it's now in my path right here. So therefore, Jupyter is in my path. Therefore, I can access it like so. Sorry, I meant to say -- version. Oops. There. Okay, so the first thing you want to do is call Jupyter Notebook -- or -- generate config. What this will do is create a folder called Jupyter.Jupyter, and in there you'll see a Jupyter Notebook config.py. It's a Python file, and we can take a look at it. It looks like this. It's a config file. We have to modify this. There are a couple of things that we're going to modify. So the thing that we need to modify is, for my personal taste, I don't want to be able to, or I don't want any of my users to be able to change the password when you log in. We'll see this when we go online. Next thing, the IP address should be the server, Jupyter Notebook server basically, is going to accept not just localhost. That means you have to log into your Raspberry Pi and then to Jupyter Notebook. We don't want to do that. We want to be able to access it, let's say, from my laptop, which is where I'm making this video. The notebook directory is going to be Jupyter Home. Now, for my personal taste, I like to put it elsewhere, but for this video, it's going to be Home Pi Jupyter Notebook. Open browser, it should be false, because whenever you type in Jupyter Notebook, the server turns on from that directory where you're working on. I don't want that. Remember, this is going to be a server which is going to be serving Jupyter Notebook, but not the browser. Password required is for sure is true. Port is 888, and this I'll leave. I'll get into this when we set up password. Okay. Now I'm going to go ahead and edit this. Now, because I'm not logged into my Raspberry Pi, what I'm going to do is I'm going to bring it, download it to my local computer, edit it, and then put it back into the what's it called? Into my Raspberry Pi. Okay, so what is my path? Okay, so what I'd like to do is, it's called scp pi. Okay, pi. SCP stands for secure copy, colon, home pi Jupyter. I don't exactly know what the name of the thing, the file is really long, so I'm just going to use asterisk pi. And where I want this is my var temp. If you're using, or you could download it if you're using Windows, download it to your desktop so that you can edit it, or if you're logging into your Raspberry Pi and you want to edit that specific file, you can just do it from your Raspberry Pi and use any of your editors. Okay, there we go. It's now downloaded. What I'll do is, because I'm using and I have these files, I'm using VS Code. In VS Code, what you can say is code and then dot, which means start your code or open this folder. Okay, so now let's start editing the the configs. So I'm going to copy this, and I'll add these in the description, the things you need to change. And I'll find it here. I'm going to uncomment this and say, turn this into false. False has to be the way you write false in Python. Remember, this is a Python file. Notebook IP. Okay, I'll look for IP. There are lots of IPs. There? Nope. Let's search the whole sentence. There we go. Turn this into an asterisk. There. Next one is notebook dir, notebook directory. Find it and turn this into home pi Jupyter /home. Okay. Next item. Open browser. This is going to be false. Password required for sure is true. And port would be 888. So let's select port. There we go. And I'm going to save it. And I'm going to do the same thing I did to send the file back to my Raspberry Pi. So it would be scp var temp Jupyter Notebook config, and send that to pi at 192.168.128.140, and it's going to be home pi Jupyter. Okay, so now copied back. Now I'm going to SSH into my Pi. Type in my password. And right now, what I should be able to do is log in and turn on Jupyter Notebook. Let's try it. Jupyter Notebook. Oh, sorry about that. Forgot to create the Jupyter Home directory. So mkdir. Remember, I said that it's going to be in here, so I don't have that directory. Mkdir Jupyter_home. Done. Let's run that command again. Good. Now we're at the password problem. Okay. Now, we can solve this problem. There are two ways we can do that. One, which is the easiest way. All you have to do is say Jupyter Notebook password. Okay, type in your password that you'd like to set. Do it again. And now what it did was it saved the password into my Jupyter directory. Let's go take a look at what the password looks like. So, okay. It looks like this. Notebook password. It's a SHA-1 digested or SHA-1 hash digest of the password that you set. The passwords are not saved as the raw passwords themselves. Instead, what they do is it saves as a hash1 digest of the string that you typed in. And now Jupyter Notebook is serving. We can then go to my laptops 192.140, my laptop's browser, type in your your Raspberry Pi's IP address and the port. And that should get you to Jupyter Notebook. It's serving off of my, type in the password that you set, and you're good. You can now start a Python 3 shell. Perfect. I can quit, and that should automatically turn off the notebook that was serving. Okay, so this is the second method of creating a password and saving it into your config file. This method is pretty straightforward. Make sure that you're using the Python from your virtual environment if you've created a virtual environment, or whichever Python you installed the Jupyter Notebook package for. So my Python is pointing to, again, just to show you, it's pointing to my virtual environment right here. So what I'll do is start a shell. Okay, and this is from, the command is from Python, from notebook.auth import password, and you can say pass pswd, enter your password. I'll just do the same thing, type in the same password twice. Oops. There we go. It generated a SHA-1 hash digest of the string I typed in. What I'll do is I'll copy this. I'll exit out of Python, go back to my VS Code, and the thing that I'm looking for is password. Okay. Notebook.password. Okay, let's look for that. .password. There. You want to uncomment c.NotebookApp.password, right? And what you want to do is type in exactly like this, u and then the SHA-1. So u, and type this in. Oops, you don't want to do it twice. And that's it. Save that. And what I'll do is I'll exit out of my Raspberry Pi and type the same command again, which is to take the newly saved with the SHA-1 password, and it will then put back into the .jupyter directory. It will rewrite the file. Okay, I can also now remove, never mind, I gotta get into my Raspberry Pi first. .json file, and it should still allow me to be able to log in using the password I had. Again, it's serving. All right, and again, type in my password, and we're back online. So these are the two methods how you can go about creating a password and storing it into a config file. Now that you've got your Jupyter Notebook server set up, here's how you can run it in the background so that your Raspberry Pi is free to be, to be used any other way. So all you have to do is type in Jupyter Notebook, right arrow key, point this to dev null 2, right arrow key again, &1 and &. Jupyter Notebook, right arrow, dev null 2 right arrow and 1 and type that in, what you get is a process ID. Now you can go into this and go into your browser, type in your IP address and the port, and you should be able to access it, which is great. But I see two problems with it. One, remember when you turn on Jupyter Notebook, you got basically a logging system into your terminal. Essentially, what you're doing right now is pointing both it's called std out and std err, meaning standard error and standard output. You're pointing them to dev null, which is just a void in your system. What if you really want to not do that and you want to see your logs later on, to troubleshoot or whatever the case, and you don't want this to happen? When you click on quit, it quits. So type in ps aux pipe grep python. None of it is running. So here's what I did. Create a directory called logs, and in there create a file called Jupyter underscore, or say Jupyter.log. Great. Now what you have to do is type in no-hup Jupyter Notebook, point this to your logs and Jupyter log, and that should point to &1 and ampersand. This way, what you're saying is point Jupyter Notebook and all of its output to logs and both the standard output and standard error to the log, and run it in the background. The new process ID is 26112, and go back in, and you're in. Same untitled, and voila, we're in. We can now close this and delete it. We can go back to our terminal and be able to see all of this into our Jupyter log there. This way, we're not losing any of our logs that are created by the notebook itself, and if we need to troubleshoot, we can always do so. So that's about all it takes to run Jupyter Notebook. In the background is a Jupyter Notebook server, and hope you enjoyed it. Thank you. Lastly, to finish up the video, let's see how we can turn off our Jupyter Notebook that's running in the background. First, ps space aux pipe grep python, and that should give you the notebook or any other Python processes that you're running. And 2612 is the process that's running it. All you have to do is type in kill 2612, and that should kill your process. And there, Jupyter Notebook is no longer running. And in fact, we can go and check. Not running. Let's go back up and do a little bit of demonstration on our notebook. Perfect. Load up the kernel. There we go. We'll look at the performance of our Jupyter Notebook on Raspberry Pi. So let's import our favorite, most common data set that we work with in machine learning or just applied mathematics in general. So you want to do iris datasets.load iris df is equal to pd.dataframe. I think it's iris.data, and columns is equal to iris.featurenames. Tab it. There we go, iris.featurenames. Okay. And that should give us our iris_df. There we go. Let's get the head. I think it's pretty quick. I mean, we are working with, and we're not doing anything fancy. We're not training a model or anything like that. But I think it's pretty fast. Let's look at a plot. We already have matplotlib plt.scatter iris_df, and let's copy the header. Depending on where you are, it could be pronounced as sepal or sepal. Again, iris_df stands for data frame. In short, either sepal or sepal with, and that should give us a nice plot. Great. I believe this is X and that's Y. We didn't really put any Y label or X label. This is difficult to remember where all the parameters go. I work with both R and Python. So for in Python with matplotlib, it's plt X label would be sepal length, and plt Y label is sepal width. There. Okay. Colors. We know that these belong to different category of iris. So color is from iris data. You can actually type in the target, not the target names, but the target, and that should give us different colors. Let's look at what the target names are. There we go. That's it. So that's pretty much your Jupyter Notebook running on Raspberry Pi. Hope you enjoyed it. Sorry for the choppy video, but I hope this helps someone. Cool.